All right, guys, welcome to chapter 15. Now, as we start building these complex advanced scripts, it's very important that we understand some of these new challenges that are going to emerge. How do we manage our code efficiently? How do we track the changes that we make? And how do we maybe even go back to a previous version if something breaks or if we work on code with other people? So, this chapter is going to introduce the solution of version control and the industry standard for it, which is going to be Git. So let me ask you a few questions. Have you ever made or changed a script that was working and then you broke it? And then you desperately wish you could have just go back in time? Or have you ever found yourself saving multiple versions of the same file with names like script final actually works? Have you ever been afraid to try a new idea in your code because it just might mess something up with the working version? Well, Git is a tool that is specifically designed to solve every single one of these problems. So the first and most fundamental benefit of Git is going to be that it creates a complete history of every change you make on your project. For every change you save, for everything we do, we call those commits. Now Git records these, who made it, when they made it, and if they're a good developer, why they made it. These are those comments. This creates an invaluable logbook for your project, so that way you know exactly what happened, when it happened, and build a really great timeline as we move through our projects. Now, because Git saves a snapshot of your project for every commit, it acts like an incredibly powerful undo button. Now, if we introduce a bug, accidentally delete an important piece of code, you don't have to panic. It's going to give us a simple command to compare different versions of our files. It also allows us to revert to a specific file or to a specific state. It even lets us roll back our entire project, known as a working version. All right, so we have some safe experimentation benefits here. And one of the most powerful features, it's called branching. Imagine you want to try a new experimental feature in your script, but you don't want to risk breaking the code that already works. Well, Git allows us to create what we call a branch, which is an isolated parallel line of development. You can work on this new feature in this new branch, and if it works out, you can merge it back to your main code. But if it doesn't, you can simply delete the branch and your stable main code is completely unaffected. When you use Git with a remote service host like GitHub, that's what we're going to use for this class, you're going to get a robust offsite backup of your entire project, including its complete history. If your computer hard drive fails, you haven't lost your work. You can simply download a fresh copy from the remote server, and this is going to let us have a foundation for collaboration. This is going to allow us to have multiple people work on the same project at the same time without overriding each other's changes. It's really cool. So before we jump backwards and jump into the commands, we're going to need to understand a few concepts with the terminology when it comes to Git. Now we need to get these terms right because it's going to let us understand how everything works. First concept is going to be the repository. The repo is what we like to call it. So the heart of any Git project is the repository. The repository is a database that stores all of your project files, its directories, and even the complete history of every change that's ever been made. When you initialize a Git in a project folder, it creates what we call a .git file. It's a hidden folder, and this is the repository itself, so please let it be. Now we talked about commit. Now the fundamental unit of change is the git commit. A commit is a snapshot of all of your tracked files in a single point in time. You can think of it like creating a permanent save point or a checkpoint in a video game. It's a record of your project that you can always return to. Now, what is in a commit? Well, every commit contains several pieces of what we call metadata. It has a unique ID, which is a long, unique string, okay? It stores all the information of who created the commit, what time. It also contains a pointer to the parent commit that it came before it, which is how Git links all the history together. And then finally, it's going to contain a message, which is a description of the whatever the developer writes of what changes did you make. So I do recommend that you make these as descriptive as possible. Like, hey, worked on this feature, modified these files, something in that nature, and it helps you in the future to know, why did you do? What did you do? What files did you change? Now, Git's going to help you with this, but it's great to also get it in human readable. Now, a branch represents an independent line of development. While it sounds complex, like we talked about, it's just a lightweight movable pointer to a specific commit. But by default, every repository has a main branch. It's normally called main. Okay? Now, the branches are going to let us do a new line of development, work on a new feature without disrupting our stable version. Now, once we are finished with the work on our branches, we can do something to integrate all of those changes back to our main code base. And this is a process that we like to call merging. A merge is a task that takes all of our changes from our feature branch and then brings them to our main branch. Now, this is going to create a new commit and includes both sets of work. But it's really cool because we can bring our extra features into our main just by merging them together. Now, let's look at some of those commands of your everyday work. Before we do anything else, the most important command that we could ever use is going to be the git status. This command is your guide. It's going to tell us the current status of our repository and what files have we changed compared to what Git has waiting for us to do next. So whenever you're in doubt of whether or not you've got the latest files, just do a git status. Now, there's two ways of starting a new project. Okay, if you have a brand new project that doesn't have any versions, nothing, brand spanking new, you can navigate into its directory and then just run the git init command. This is going to create a new empty repository. More commonly, if you want to work on the project that's already hosted in a service like GitHub, you'll want to do a git clone. Now, the git clone is going to require you to have its project URL. This will download a full copy of the remote repository to your local machine. Now, the process of saving your work in Git is a two-step process. And you'll have to know how to do this because you're going to repeat this constantly. First, after you made some change in your files, you'll use the git add command. This is going to move those changes into what we call a staging area. This is going to tell Git what changes you want to include in your next commit. Second, you'll use your git commit. And hopefully you're using your -m flag because you're going to provide it a message. This is going to take everything from the staging area and permanently save it as a new commit in your repository's history. Now, we keep talking about branches, so if you want to do a new branch, you could do it this way. Once you want to work on your feature branch and you want to bring it back, it's a two-step process. First, you want to merge it into main. So what we're going to do is run a git merge. I think I skipped ahead a little bit. So working with branches, first we want to create a branch, right? It's very simple. You'll use the git branch followed by the name of the branch itself. Maybe it's the feature name that you want to work on. And then once you start working on that branch, you'll do a git switch. Now what this is going to do is it's going to switch over to the new directory structure for the new branch. And then once you do that, you'll do a git switch -c, which will create a new branch and immediately switch you to it all in one step. So instead of doing git branch new feature, git switch new feature, you could just do a git switch -c new feature, and it will do a create and switch to you automatically. It's really cool. Then you'll work on your changes, move on, and then when you're ready, now we'll merge it back into main. Now, of course, we're only going to do this when it's completed and tested, and remember, it's another 2-step process. What we want to do is we want to merge it back into main. So what we'll do is we'll switch our branch back into main by doing git switch main, and then a git merge, and then the feature we want to merge into main. So we need to be in the destination area and then pull the branch into where we want to bring it. And in this case, we're bringing it back into main. Now, sometimes we want to work with remotes to back up our work or something like that. Or maybe we want to collaborate as a team. So we'll need to recreate a remote repository. These are versions of our projects that we can host onto a centralized server. Now, most of the time in this class, we're going to be using GitHub, but there's GitHub, GitLab, Bitbucket. There's a ton of them out there. Some of the other commands that we can deal with this is we can do the git pull. Git pull is used to fetch the latest changes from the repository and merge them into our local version. You should do this regularly to keep your project up to date with any changes that your teammate has made. Now, a git push is the opposite. It uploads your local commits that have not yet been saved to the remote server. This is how you can share your work with the rest of your team. All right, I got a little stumbly there halfway through, but hey, to summarize, this is going to be how we use Git. It's great for version control, and it's going to be absolutely essential for skills for anyone who wants to write code or manage configuration files that are going to be complex. In this chapter, we've learned the reasons why we use Git, from its powerful history to some of its safety features to its collaboration and backup utilities. We now know what a repository, a commit, and even what branches are. We talked about branches quite often. And now you're even familiar with the fundamental workflow on how we change our local changes, our branching, interactive, remote repositories. And now these are all going to be muscle memory. So for you to actually become a professional developer or system administrator, just know that this isn't going to just come as easy for some people. You will just need to just have some practice with it and make sure that you're going through it slowly and just use it. Now, I don't care if you're a team of 1 or 20, the Git language is amazing for backing up your scripts because you never know when you're going to need to go back to those scripts. So I do like to recommend using Git. Now, there are some more advanced features of Git, like public and private repositories, so be very careful what you publish to a cloud-based repository, because I have seen many security instances where somebody puts their passwords or API keys in their code and then uploads it to Git as a public repository. So be careful how you do this, guys, but it is a great tool to have because we're all going to make mistakes. Now that's going to be the end of chapter 15. I hope that through chapters 1 through 15 on this course, you've learned something. We dealt with Bash, we dealt with PowerShell, we dealt with Python. We've learned how to integrate it with MicroPython and a lot of IoT devices. Heck, we even started with Smaldrino Unos. Now, in the next few chapters, all we're going to do is start practicing more of these projects, okay? So as we move through the rest of the course, start thinking about those final projects. How would you want to showcase what you've learned into a final project? All right, I'll see you for the next video. Keep on programming.